All right, we have one more example. In this case, everything's really generalized. Okay, we have a metal plate with a constant density of delta, and the shape that is bounded by the curve y equals f of x. So we don't even really know what f of x is. It's bounded by that and the x-axis between a and b. So let's just draw a very general curve. All right, so here's my y-axis, here's my x-axis, and I'm going to draw this curve, and I'm just going to draw some squiggle like that. Okay, and so we want to, this is our f of x, and we want to integrate it, or we want to look at the region that's bounded by a and b. So I'm just going to put this here. There's b, and we want to find first of all the total mass here. Now this is really nothing different, right? We're going to basically look at slices. So we have slices that are delta x, y, and y tall. Now y is equal to f of x. So so I can just write that down, I suppose. And so the total mass is just equal to the integral from a to b of the density, right, times f of x dx, right? Because this f of x dx essentially represents the area of one slice. And then we take that times the density, right, to get the mass, and then we're just adding up all the slices using an integral. All right, also we can look at the moment about the y-axis. All right, now to find the x-coordinate of the center of mass, we need the moment around the y-axis, and we've got it sliced nicely in a vertical direction, so we can again just use these same slices to find that the moment around the y-axis is the integral from a to b. Okay, and now we're going to take the sum of all those masses times the distance from the y-axis, and the distance from the y-axis is just x. Okay, and then the mass is the density times the height of that slice, which is f of x, times the width of the slice, which is dx. Okay, so that is our moment. And then if we want the x coordinate of the center of mass, it's just going to be my over the total mass. Oops, the total mass. And so we get the integral from a to b of x f of x. Oops, forgot my delta. Hang on, just get an eraser. Make this nice. Delta f of x dx. Okay, that's the moment, and then the denominator is just going to be another integral from a to b, and it'd be the integral of the density times f of x dx. Okay, there's nothing new there. But what I want to show you here is when we go to find the moment about the, about the x-axis to get the coordinate, the y-coordinate of the center of mass, we have a little problem, because if we try to slice, let me just, if I try to slice this, it's fine down here. I can easily slice it down here, right? But I'd go, if I get up here, now I just drew an arbitrary function. But the problem is that this is not a one-to-one function. Got a weird pen here. I don't know. So we can't really, once we get to a certain point, if it's not a one-to-one function, where it's invertible, it's not nicely invertible, then it's hard. We can't. There could be sections where it doesn't pass the horizontal line test, and so it's not easily sliced in that horizontal direction. Okay, so we have a little bit of a problem. So what I'm going to show you is an alternate way to find the moment around the x-axis by using these vertical slices instead of using horizontal slices. Okay, so I'm going to actually redraw. I'm going to redraw my, let's see, so I'll put it right here. I'm going to redraw this this function. Okay, so we have x and y, and then I have some function that has some little curve like that. Okay, so that's f of x, and we're integrating it from a to b, and we're going to take slices in this direction, in this vertical direction. So we have delta x. Okay, so the question is, how do we went now to find the coordinate of the y coordinate of the center of mass. We want the moment around the x-axis instead of the y-axis. But if we take these vertical slices, right, where again we have a constant density, right, and so we know for that vertical slice where that's nice and thin, the position of the center of gravity of that slice is going to be essentially 1/2 f of x. Okay, that's our center of gravity, or center of mass for that one slice. All right, so we can actually find the moment around the x-axis of one slice. So in this case, a vertical slice, by taking 1/2 f of x. Okay, so we're going to use that as the center of mass for that slice, and that's our distance from the x-axis times the mass of that slice. So that's going to be the delta f of x delta x. Okay, so this is our mass, right, and this is our distance. Okay, this is our distance because effectively the center of mass of that slice is effectively the distance for that whole slice. All right, now, I know that might seem a little strange, but then it allows us to write a formula for the moment about the x-axis while integrating in the x direction. So we don't have to worry about trying to invert the function, because in this case it's, the way I have it drawn in general function is not invertible. All right, so the moment about the x-axis is the integral from a to b of 1/2 f of x times this delta f of x. So essentially we have f of x squared. So I'm going to put those two together. So I can have 1/2 delta f of x squared dx. Okay, and so then the y coordinate of the center of mass is mx over the total mass, right? So I get the integral from a to b of 1/2 delta, that's just a constant, f of x squared dx, all right, over integral from a to b, of, so this is just the mass function that we had before, so delta times f of x dx. Okay, so that's just an alternate way of finding the y-coordinate without having to slice things perpendicular to the y-axis. And you'll see these in these formulas, maybe if you take some physics, or if you're taking something like statics, if you're an engineer. So we have these two formulas that we can use. I'm going to put little squares around them because this is kind of our final result. Now, I would encourage you to actually try this out. And you can actually try it on that problem, example 6 that we just did. So in example 6, to find the y-coordinate of the center of mass, we sliced it horizontally. So try it again, slicing it vertically, and see if you get the same answer, because you should. I tried it, it worked. But I'm not going to go through it here because I've obviously, this section has gone a little too long. So, so anyway, I'll let you work on the discussion questions, and I'll see you in class.